All right, how you doing? I'm your man, John Wilson. We got a good one for you today. We're going to finish up Module 4. We're going to do 4, Lesson 3, and 4 today. Specifically, we're going to understand how to graph a line from an equation using the slope and the y-intercept. And then we will understand how to distinguish between proportional and non-proportional situations. The good thing is, you've already done all of this without even knowing it. Wait till we get there, you're going to be like, why are we? I know how to do all that because I already taught you all of this stuff while we were going through 3 and 4. This is the newness today. This is the new stuff. You know what slope is. You know what y-intercept is. Now I'm going to teach you how to graph a line using the y-intercept and the slope. Then the good thing is, if we have the y-intercept, you already have one of the points on the line? Yes. Yes, I do. Then we just have to find another point or 2, maybe 4. Why not? All right. So, to graph a linear equation in slope-intercept form, we must remember what M and B represent. Gotta remember that. Gotta know what the M is, gotta know what the B is. So we look at this equation right here. Y equals mx plus b. Let's see, this is just a quick review. Let's see if we remember what it is. Core, what does the M stand for? Just the M.
Slope.
M stands for the slope. Shimon, what does the B stand for? Y-intercept. What's another name? When we're talking about the y-intercept in the table, what's it called? 2 words. Ali, what's it called?
Initial value.
Initial value. You must know that the y-intercept is also known as, I want to write this in, the initial value. We have another name for slope too, right? What's the other name for slope? 4 words. What is it?
Rate of change.
You're missing one of the words. That's 3 words. You're missing something. Something comes before rate. What is it?
The rate of change.
The what?
The rate of
No, not the rate of change. Rate of change. The rate of change. Lucas, what do you got?
The unit rate.
No, not the unit rate of change. What do you got?
Constant rate.
Constant rate of change. The Crocs, the ugly shoes. Constant rate of change is the slope. Adios. Is the slope. So you can also say, you might want to write this in, it's also known as the constant rate of change. Got to know all the names for it. Constant rate of change is also the slope. Y-intercept is also the initial value. Now to graph this equation, we have this equation right here, which is y equals 2 over 3x plus 1. To graph this equation, the first step is to graph the y-intercept. So looking at this equation, we must identify the y-intercept. If you look at this, Emily, looking at this equation, what's my y-intercept?
Oh yeah, the 2 over 3.
That's slope. What's the y-intercept?
1.
1. But be careful. Make sure that when you're talking about the y-intercept, always include whatever symbol is here. So this is a positive 1. It's not really as important for positive. It's real important if this was a minus 1. There's a big difference between a positive 1 and a negative 1, right? Or a positive 2 and a negative 2, positive 3 and a negative 2. There's a big difference. Make sure that this symbol is part of what you're talking about. So that's my y-intercept. Positive 1. Now to graph it, I need the y-intercept's coordinate pair. Sean, what is the coordinate pair that represents that y-intercept? Sorry. What would the x value be? Y is 1 of the y-intercept. No, that's not the x value. Guys, what would the coordinate pair be for the y-intercept? I got one hand up. I should have a lot of hands up. Okay, let's just see here. Flash, you know what it is? What's the coordinate pair? No, it's not 2, 3. All right, guys, hold on. Let's pause here. Let's examine this. When I have a y-intercept, that's where the line crosses which axis? The y-axis. A y-intercept crosses the y-axis. If I'm on the y-axis, what's the value of x have to be? Anybody?
0.
What is it?
0.
0. So the coordinate pair for this y-intercept would be what?
0, 1.
0, comma 1. 0, comma 1. That coordinate pair is going to be the first point I use whenever I graph a line. Always graph the y-intercept first. So I'm going to take this and I'm going to graph my y-intercept. That's the first point. truth is, to graph a line, I really only need 2 points. I'm going to show you how to graph 1 point, then I'm going to show you how to graph 2 points, and then I'm going to show you how to graph 4 points in different directions. You really only need 2. I want you to get in the habit of graphing 4 additional points when you graph a line, so you can really see what that line looks like and how it stretches from one end of the graph to the other. Whenever I have you guys graph a line, you're always going to end up doing 4 points. I'll work you up to that. Right now, everyone should have that one little point graph. Do you have that?
Yeah.
And this, let's just make sure we understand what this is exactly. This is the y-intercept.
Y.
This is my y-intercept, and what's the coordinate pair?
0, 1.
0, 1. So we don't know what this line looks like yet. It could look like a lot of things, but we know that the line passes through this point. Now we got to figure out what this line is going to look like. So let me quickly regraph that point, and we'll continue on with this. Quickly regraph that point. You're moving down to the next part of your notes. Regraph that point. You're still working with the same problem. So we know that the y-intercept here is 0, 1. We know that. What's the slope of this equation? Anybody? Slope. Calco, what's the slope?
2/3.
2, 3. That's my slope. That slope right there, that 2 over 3, or whatever the slope is, doesn't matter if it's a fraction or a whole number, whatever, that slope gives us the information that we need in order to graph additional points on this line. Just to make sure you understand that I'm not just making this up, exactly what this slope represents. The numerator is which value, the y or the x? It's always the y, always y over x. This 2 represents this triangle here. This means change, in case you're wondering. Whenever you see a triangle, that means the change in y. So 2 is the change in y, positive 2. So every time we move up a point, it's increasing by 2. 3 is my change in x. My change in x is a positive 3 or negative 3? Positive 3. So that means as this line goes across the graph, it's going up 2 and it's going to the right 3 spots. Yes?
If the 3 was negative, does that mean the whole fraction was negative?
We'll get into that. We will. But yes, if the numerator was negative, it means the whole thing's negative. Now be careful. Let's just make sure I'm clearly understanding. If we have 2/3 and this was negative, that means that this is, negative 2/3. It does not mean that it's negative 2 over negative 3. It does not mean that. Because 2 negatives would make this positive. Okay? But we're going to get into negatives and how we graph negatives and all that. But yes, if you had a numerator or a denominator that was negative, it doesn't mean that we're talking about a negative fraction. If they're both negative, simplify into a positive number. Okay? All right. So, most important thing you can do when you're graphing is identify what the numerator means. The numerator, the top number, the y value, determines if we go up or down. Now, we always have 1 point graph. What's the point you're always going to have graphed? What's this called? My y-intercept. The numerator is going to tell me from the y-intercept to get to the next point if I have to go up or down on the y-axis. The denominator is going to tell me if after I go up or down, I have to go right or left. If the numerator is positive, what do you think I'm doing? I'm going up. If it's negative, I'm going down. If the denominator is positive, I'm going to be going right. If it's negative, I'm going to be going left. So let's examine here. My slope is positive 2 over positive 3. So if I have a slope of positive 2, the numerator is positive 2, am I going up or down? Up. So from the y-intercept, I'm going to go up 2 points. And then I have to go what? Right or left?
3 right.
3 to the right. From the y-intercept to get to the next point. Write that in. I'm going to show you exactly how it's done. Once you write all that in, I'm going to show you how we get from the y-intercept to the next point. So once again, this is positive, we're going up. This is positive, we're going to the right. Now, when you're moving to the next point, where are you going to start at? From what point? Not 0, 0.
No.
What's the one that we know?
0, 1.
We know 0, 1. We know the, and what is that again? Y-intercept. You're always going to graph the y-intercept first, and then you're going to use the slope until you have to get to the next point. So from here, to get to the next point, we have to go up 1, 2 spaces, and then we have to go to the right. How many spaces?
3.
3. 1, 2, 3 spaces. Could I graph another point doing the same thing? Yes, I could.
Yeah.
The line continues. Doesn't this line continue on and on and on forever and ever and ever?
Yes.
Yeah, so from this point, if I want to get to the next point,
2.
I'm going to do what?
2 up.
I'm going to go up 2, I'm going to go right, 1, 2, 3 spaces. Could I graph another point here?
Yes.
Yes, I could. What can I do?
Again.
I can go up 2, and to the right, 3 spaces. So I have a whole bunch of points there now. Whole bunch of points. What do I need to do? I need to connect the dots. So I'm going to connect my dots with a line. And then what do I have to have on the end of either line? On the end of either side of the line?
An arrow.
A little arrow. Little arrow here. Little arrow here. That indicates that this line goes on and on and on forever in that direction. It also goes on and on and on forever in this direction. Yes?
You always have to put a line in the arrow.
You always, once you're done graphing your points, yeah, you're always going to connect your points with a line because we are graphing a what? A line. And then once you have the line graph, yeah, you will put an arrow at either end of the line. That's to indicate that the line goes on and on forever and ever. If you don't have that, let me ask you a question. Does the line stop right here?
No.
Does the line stop right here?
No.
No, it keeps on going, right? So we need something to indicate that it does keep on going forever and ever. So we draw a little arrow, little arrow. That line keeps on going forever and ever and ever. Goes from here, shoots up into the atmosphere, right to the window, to the roof anyway, then through the window out in the other classroom up there on the 2nd floor and goes off into space. This one right here shoots down through the floor in this direction and keeps on carving a path until it comes out in the middle of Tunisia, right through somebody's backyard, and then shoots out into space on the other side of the planet. But it keeps going on and on forever and ever and ever. We must indicate that with the arrows. Any questions on this first one? This is just introduction. We are not moving on past this anytime soon. We're going to keep doing it until you guys understand exactly what it is we're doing. But any questions on it so far? Any questions? Yes. I know. Any other questions on this? Any questions? Any questions? Okay. So, 4, 3, 2, 1 on this. All right. So now we're going to repeat the process. We are now going to graph 2 additional points. Last time I just did it quickly, but I want to make sure that all of us here can graph this into additional points. But there is something a little different here now.
Negative.
When we look at this, we have a negative y-intercept, and we have
a negative
slope. And I'm going to explain to you what happens in these circumstances. Let's start by identifying the coordinate pair of the y-intercept. Let's go to, shuffle these up a little bit. Let's go to my homie, Corey Gonzalez. KG, are you with me? I need the coordinate pair for the y-intercept.
0, -1.
0, -1. Once you have that y-intercept, that's always going to be the first thing you graph. 0, -1. In case you don't know where that is, it's right there. You start at the origin, it's -1, you go down 1. Put your dot. That's it. Now, we need to graph some more points. So we need to look at the slope. We do not want to let these negatives confuse us. That's why I put this thing here with a star, big box. Read along with me. When your slope is a negative fraction, only one of the values is negative. Either the numerator or denominator for continuity. Let all of you vote for continuity. What? For continuity, I'll read it then. For continuity, we will initially make the numerator the negative value. Sounded, anybody here watch The Walking Dead?
Yes!
Sounded like a herd of walkers. Continuity. Okay. So I'll read it again, just me. When your slope is a negative fraction, which is what we have here, a negative fraction, that's not a pin, that's a pin. When your slope is a negative fraction, only one of the values is negative, either the numerator or denominator. But for continuity, we will make the numerator the negative value. The reason for that is, what happens if they're both negative? It becomes positive. It doesn't truly matter which one you make negative, but just to have a good process, just to have something that's continuous when you write these out, we'll always make the numerator negative. Question?
Well, haven't we gotten coordinate pairs before where they're both negative numbers?
We're not talking about coordinate pair right now. We're talking about slope, a negative slope in a fraction.
Okay.
That's what we're talking about. Very specific thing here. But yeah, we have had negative coordinate pairs. So, to get to the next point from the y-intercept, oh, thank you. For being honest, it's your take. I will take your sunflower seeds as payment. I'm just kidding. You can have this back. All right. What that means is, when we write this out, in case you want to know if you go up, down, right, or left, that means that very specifically, we make the numerator the negative number. So it's going to be a negative 4 over a positive 3. We need to know that because we have to know what direction to go to get to our next point. So this is going to tell me very specifically, from my y-intercept, if this is a negative, my numerator, am I going up, down, right, or left? What do you think?
Down.
I'm going to go down how many spots?
4.
4 spots. Once I go down 4 spots, I'm looking at my numerator. Am I going to go right or left?
Right.
Right. How many spots?
3.
3 spots. Sorry, denominator. Yeah, I'm looking at my denominator. Speak so quickly, I messed up the step. So, to get to the next point from the y-intercept, we must go down 4 and then right 3 spots. Did you guys write that in? And then we're going to go graph that next point. Okay. Emily, when I graph the next point, I'm starting from the origin, right?
No, you start from the 0, negative
1, which is known as the y-intercept. Good. When you graph the next point, you start from the y-intercept because you'll always have that graph first. So I'm going to start here. Emily, am I going up or down?
down.
Down. How many spots?
4.
4. 1, 2, 3, 4. Notice I'm not putting a point there. That's not where the point is. I now, before I graph my point, do I have to go left or right?
Right.
How many spots?
3.
3. 1, 2, 3. And I have to put a point right there. I want to graph another point here. So from this point, not from the y-intercept, because that was just taking me to the same spot. From this point, where do I go, Emily?
You go down.
Down. Yep, I'm still down. Down 4. 1, 2, 3, 4. And then?
Right 3.
1, 2, 3. Once I have those points graphed, what is the last thing I do? Oh, she's not here today. No name is not here. She who shall not be named is not here. Fiamma, a.k.a. Moneybags. What's the last thing I have to do?
You have to connect them, connect the dots, like with a line.
Okay, so I have to connect the dots with a line. And what I'm going to do is, I'm going to start, and I'm just going to graph my line right like that.
You draw lines so perfect.
That's because I got the line,
I know.
the little line writing tool makes my job easy. Draw my little arrows there, draw my little arrow there, and boom, I have the line. In case you were wondering what I was revealing here, it's exactly what we did. Once we graphed the first point, we got to the second point, to the last point. We went from 3, negative 5, we went down 4 and right 5. Again, right 3. Right 3 to get to the next point. That should be a 3. Cross that out.
So then
That's a 5. That's a typo there. That should be 3. Yeah, this should be, no, this is saying that this is the point. So when we were here, this was 3, negative 5.
Oh.
So if we look at this point was 0, negative 1. What was this point? Let's see, 3, negative 5. And then,
6,
what was this last point?
6, 8,
comma,
negative 8,
negative,
8,
let's see, hold on. 1, 2, 3,
8.
4, 5, 6, 7, 8, 9.
9.
It's 6, negative 9. You have to be able to identify the points that you graph as well. Yes? How did I get negative 5? I started here at 0, negative 1, right? And then from here, I went down 4, I went to the right 3. So if you want to identify what this coordinate pair is, start at the origin. To go from here to here, do I have to go right or left? How many spots? 1, 2, 3. So I'm directly above it. Now to get from here to here, do I have to go up or down? How many spots? 1, 2, 3, 4, 5. That's how I got that. The coordinate pair is 3, negative 5. What's up?
On this graph, we only know 3 points, and on the other graph, we know 4.
Yes.
We just go to the graph to the graph ends.
I just wrote 2 on this one. I was just showing you some additional points in the last one. On the next graph, I'm going to show you, so far, we've only been graphing in the direction the slope has told us. I'm going to show you on the next slide how we graph in the opposite direction. But you can graph as many points as you want.
Oh.
Just make sure that you can identify, very important, identify the coordinate pairs. Okay, what's up? Because we are on, if you look at the x-axis, this is the positive side of the x-axis, right? So to get from here to here, from the origin, did we go right or left? We're going from here to here.
Oh,
We're going right, 3 spots. So that means on the x, this is a positive 3.
oh.
And then on the y, we're not on the positive side, we're on the negative side. So we had to go from here to get to here, we had to go down. 1, 2, 3, 4, 5. So the y is -5, which gives us this coordinate pair. Okay? What's up? Well, oh, you did take it. All right. Lo siento. Look at her, you know, got all the money in the world, still asking for extra. It's okay. It's okay. Questions on this? Questions? 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 Okay. Woo! 4 additional points. But in case you were trying to work ahead, please don't, because I want to make sure that you're graphing the points that I want you to graph. And then we're going to identify all the coordinate pairs. Same process, though. Same process. Y equals 2x. What's my y-intercept? Let's think about this. What's your y-intercept?
Oh, no, like y would be 0.
Because there's no y-intercept. In the absence of a number, it would be 0. And that makes sense because this equation here represents a proportional relationship. And a proportional relationship must go through the origin, which means the y-intercept has to be 0, 0. So my y-intercept is 0, which means that the coordinate pair for this would be 0, 0. That makes sense. If I don't have a plus or a minus here, that means that my y-intercept is in fact 0. This is a proportional relationship. That takes us all the way back to module 3 when we were writing equations. Remember this? Y equals kx? Remember that? Way back, same thing. This is the equation for a proportional relationship. K is the constant of proportionality, which means it must go through the origin. That's why our y-intercept is in fact 0, 0. All right. So this time, though, we don't have a fraction, do we?
No.
I need a fraction in order to know if I'm going up, down, right, or left. The good thing is I'm pretty sure that all of you in here know how to turn a whole number into a fraction. Am I wrong?
Yeah.
Do we know how to make a whole number a fraction?
Yes.
Yes, just in case we're not clear, let's try this. I'm going to give you the number 1, 2, 3, and 142. Why not? Okay. Let's turn this into a fraction. I have to put it over 1. Turn this into a fraction. I have to put it over 1. Hey, nobody said 2. That's good. I thought there was going to be somebody saying 2. Turn this into a fraction. We put it over 1. Turn this into a fraction. I put it over 1. 1. Not 142. Not 1 million. 1. This is how you turn a whole number into a fraction. It also works with a decimal. What's 3.5 as a fraction? 4.5 over 1. It's the same thing. Okay. We're just working with whole numbers now. So I want to turn this into a fraction, which means I'm going to put 2 over 1. 2 over 1. This becomes 2 over 1. So from the y-intercept, to get to the next point, what do I have to do? Do I have to go up or down?
Up.
Up. How many spots?
2.
2. And then just Sean. Sean, after I go up 2, what do I got to do, man? What do I got to do?
I go to the right
1 spot. Up 2, because it's positive. Right 1, because it's positive. So let's graph 2 points in that direction. We're going to go first in this direction along the line. Then I'm going to show you how we can actually go back in that direction using the same slope. All right, so let's graph those points. Where'd they go? Oh, right there. Okay. So, come here. Not all of you, just one of you. Not all of you, just one of you. Thank you. All right, so Shimon, from here, what am I doing?
You're going up 2.
1, 2.
And
1 right. Notice, this is a common mistake here. Do I put a point here?
No.
No. You don't put a point until after you go up and to the right, or up and to the left, or down to the right. You must do both things. Up and to the right, up and to the left, down to the right, down to the left. Whatever. You must do both things before you drop your point. So I drop my point there. We'll graph another one in that direction. Now, when I graph this point, am I starting back from the y-intercept? No. Where am I starting from?
The second point.
That's second point right there. And we're going to graph Miss Vega. From here, where do I go? Up to the right one. Good job. You can take us there. Now I want somebody to help me. Let's grab some cards here. Oh, that's not. Let me grab that. That's for you. Let's identify these coordinate pairs real quick. Let's go to my homeboy, my main G, Matthew Slam Tanner. Slam Tanner. Start off by identifying this one. What you got?
0, 0.
0, 0. That's good. What's this one?
2, 1.
That's backwards.
Wait, no, 1, 2.
Yeah. So at the origin, you go right 1, up 2. So this is 1, comma 2. Okay. What's the last one then?
2, 4.
2, comma 4. Okay. Perfect. So we know how to graph in the direction the slope is going. But what if I needed to go instead? We know that this line continues in this direction as well, right?
Yeah.
We know that it goes this way. We know that it goes this way. What if I want to go this way? What could I? Did you have a question, Sydney? Because you had your hand up. You had a question? What's your question?
Can it ever go left? There's always right. Like,
Oh, it could go left. I'm going to show you that right now. Maldonado, what do I do if I want to go in the other direction?
You can go left 1 and then down 2.
I could, but how do we determine that we're going left 1 and down 2? How do we determine that? Well, okay, so we're making it negative. We would just make every number negative. What if it's already a negative number? How would we make that negative?
you go up positive. Oh, just
I'm trying to get you to say a certain word here. Sometimes it is necessary to graph a line in the opposite direction, Maldonado. To do this, we must find the, when I say opposite, what comes to mind? What are those words? Starts with an I.
Inverse.
Inverse. We must find the inverse or opposite values of the slope and then graph those points. So my slope was positive 2, positive 1. What's the inverse or the opposite of a positive 2?
Negative.
Negative 2. What's the inverse or the opposite of a positive 1? Negative 1. So if I want to graph in the opposite direction from the y-intercept, I find the inverse values of the slope. I go back to my y-intercept and I just roll out in the other direction, man. So if we want to go in the opposite direction from the y-intercept, now that we've reversed it, what am I going to do? Up or down?
Down.
Down, and then Sydney, go to left.
Left.
Left, and I would go left 1. Let's grab 2 more points, and we're done with this happiness. All right. Sydney, from here, I'm graphing the opposite direction. What am I doing?
Go down 2.
Go down 2,
And 1.
and to the left, everything you own in a box to the left. Why couldn't you put the box to the right? No. All right. Now, to go to the next point, what do we do?
2 down.
2 down,
1 left.
1 to the left, and you drop 1. Good. We've graphed in the opposite direction. That's key right here, by the way. This, the reason it has its own little section, that's key. You must understand how to graph a line in both directions from the y-intercept. Calco, what's up, dude?
Question, wouldn't that be positive?
We want to be positive.
Because you have -2 and -1, wouldn't that make that positive?
But we're not worried about the number right now. We're not worried about what number it would make. Technically, yes, those would make a positive. What we're worried about is trying to find directions for our slope. We're trying to find the roadmap, if you will, from how to get to the y-intercept in the opposite direction of the line. Yes, good observation. If we were going to simplify that, if the question was to simplify that, yes, it would become positive. What we're doing, though, is this is just a roadmap. It tells us how we get from here to here. We know how to get from here to here and from here to here. But if I want to graph in the opposite direction of the y-intercept, I just take the inverse of both numbers. And if they're positive, both numbers, yeah, it would look like they're both negative. Don't oversimplify. Don't have to overthink this. This is just simple, reversing the numbers to go in reverse. Think about a car, right? You're going forward, you want to go in reverse, you got to put the car in reverse. Everything's backwards. So instead of a positive, 2 negatives. Instead of a positive, 1 negative. Okay? That's all we do. We're just driving an auto. Let's identify some points. But Dyson, I want to know what this point is, right?
-2, comma 1. Comma -1.
Let's start from the origin. Start from here. To get from here to here, I have to go left to right.
Left.
Left. How many spots?
1.
1. So it's -1 on the x, and then I have to go up or down.
Down.
Down. How many spots?
2.
2. So it's -1, comma, -2. That's my points. All right, be careful. I know. And that is horribly written. Hold on, let me make this a little bigger here. Everybody can see this. We got -1, comma, -2. Okay. Madison, let's redeem ourselves right here. What's that point?
-2,
Comma.
comma, 4.
Yes! Yes! That'll wake you up, huh? -2, comma, -4. Bam! She got it. Whoop, whoop! Yes! Good. -2, comma, -4. And then, why did somehow my point just disappeared over here? Just disappeared off. Finishes up. Jennifer Gutierrez. What do I do? What's the last thing? I must connect all the points with a line. I gotta put a line through all of them. Right now I just got a whole bunch of points, man. We are graphing a line. So what we're gonna do now is we're gonna graph this line right here. And then to finish it up, what do I have to put on the end of each line? Arrows. Ba-bam, ba-bam. Ba-blam, blam. Good job. Hold on with that one. And I gave you a ticket, right? Yeah. Okay. Good. Any questions on this? Any questions? Any questions? Yeah. Magic! It's possessed!
We are.
So,
What about the red?
Oh no, we have this, that's right. Oh, curses. Oh yeah, this is the easiest stuff in the world. Though. Yeah, this is the easiest stuff in the world though. But this is 4-4, so it's a quick review. This is a quick review. Anyway, let me rewind this. And, alright, so now we're going to do 4-4 right here. We're going to identify proportional and non-proportional situations from a graph, table, and equation. The good thing is, the awesome thing, you've already learned most of this. Now, if you look at equation, if you want to tell if it is proportional, the line must pass through the origin. So, let's just go through this real quick. Let's do some quick tickets. Let's go to, who has not gotten called on today at all? Let's just start with Connor. What is this?
That's proportional.
Cartlef, what is this? Okay, and Viviana, what's this? Beautiful. And then Maldonado, what's this? Proportional. Good job. That's from a graph. Simple stuff. We know how to do that. Now, in an equation, for it to be proportional, in an equation, the y-intercept must be what? We talked about this. What does it have to be?
0.
0. Your y-intercept has to be 0 for it to be proportional. Because if the y-intercept is not 0, does it go to the origin?
No.
Yes or no?
No.
No. So, looking at this first one, what's my y-intercept for this equation? 0. Do we have a y-intercept here? No. In the absence of a y-intercept, technically this is plus or minus 0. So, is this proportional or non-proportional? Proportional. Good job.
What's that at the top right there? Where is it equal to?
Oh, it must be equal to 0. Must be equal to 0. Okay. Bolaños. What is this? Proportional or non-proportional? Proportional because my y-intercept is 0. Good job. Jennifer, what is this? What's my y-intercept there?
0.
What's my y-intercept there? Remember, think about this equation. Line equals mx plus b. B is the y-intercept. So what's my y-intercept here?
4.
So if my y-intercept is 4, that means this line is going to go through right there. So is that proportional? No, it's not. So this is non-proportional. Let's try another one. What about this? What is that? Non-proportional because my y-intercept is -3. That would mean that if I were to graph this, it would go through right there. Okay? So just keep in mind that as long as you don't have a y-intercept like this, it's proportional, or if your y-intercept is 0. And pass that back to Emily for. Okay? Questions on any of this? Let's just make sure we have this down pat. All right. Y equals, y equals, y equals.
Is that our report?
No. Okay. Is this proportional or non-proportional, class?
Proportional.
Proportional, because this is the same as writing 6x plus or minus 0. So my y-intercept would be 0. What about this? Proportional or non-proportional?
Non-proportional.
Non-proportional because my y-intercept is -4. Don't say 4, it's -4. And then this one, let's make this negative. No, let's not. Let's just make it 5x. Is it proportional or non-proportional? Proportional. And somebody had a question. What's up?
You put positive or negative 0.
Because it's, I mean, there's nothing. Just plus 0, minus 0, right? It's the same thing, right? The y-intercept would be 0, right?
Yeah.
If the y-intercept 0, that means that it is proportional. I just wrote this to illustrate a point. You can have 5x and 5. Just having 5x is the same as writing plus 0. It's the same as writing minus 0, right? Either way, the y-intercept here would be
0.
0. Okay, good job. Any questions on that? What's up?
Can you make it like, what happens if it is like y equals 5x and it will be equal to open parentheses and you have a subtraction where it will be equal to 0?
It would be 0. There's no number there would be equal to 0. Okay? All right. And the last one, you've learned this as well. How can you tell if something is proportional from a table? You have to find if there is a constant. Somebody said it was an R. Ratio. There has to be a constant ratio between y and x. We did this in the beginning of Module 3 about 2 weeks ago. So we put y over x. What's 12 divided by 3?
4.
4. What's 36 divided by 9? 4. What's 84 divided by 21? 4. Do we have a constant ratio here?
Yes.
So is this proportional?
Yes.
Yes, it is. We try this one right here. Anybody know what 22 divided by 4 is?
It's a decimal.
5.5. What about 46 divided by 8? What do you think that is?
It's 5.75.
5.75. Do I have a constant ratio?
No.
No. Do I have to do this one?
No.
Absolutely not. If I did, though, I would get 5.8. I do not have a constant ratio, so is this proportional?
No.
No, it is not. That's the easy stuff. We just finished Module 4. No, that's just an additional example. All right. Questions? Yes. When you divide it, you must get the exact same number. They were all 3.3 repeated. It would be proportional, yes. All right. 4, 3, 2, 1 on this.